Hello, sir. Am I audible to you? Hello. Hello. Can anyone confirm if sir is there? Am I audible to anybody?
Yes, sir, you're audible, but sir is not there.
So if anyone in the class can confirm from sir.
Hello, hello.
Yeah, hi. We are waiting for sir to start. The message. I got the message on WhatsApp, and sir said to wait for a few minutes.
Yeah. Can you just hear me now?
Yeah, I can hear.
Yeah, you can hear me.
Yes.
Yeah. So for on the, please say yes or no, okay? Because if you're
Sorry.
shy, Ronald is here, Lucky's. Oh, rest of them are gone. Okay. What happened to the rest of you? Can you send? Abhishek is joining. Oh, okay, okay. There are quite a few people. Okay, Anurag is there. John, Abhishek, Punita. So 1, 2, 3, 4. There are 2 people here, 6, still 4 missing. Okay, so I think Afzal,
Yes.
you should be able. You are co-host now. Please do share,
Sure.
and you can start. There are 4 people missing, but hopefully.
I hope you can see my screen.
Yeah, now we can.
Okay.
And also record it.
Yeah, sure. So just
Yeah.
one thing, today my Wi-Fi is not working, so I'm connected with mobile internet. So if in case in between, if my voice is there, just let me know.
No, you are coming through. Okay.
Yeah.
There's a little bit echo, but that's okay. Can you make your, oh, but you can't make your screen big. Then you can't be able to write, no? So you can Yeah, reduce the volume a little bit so that that echo might go away. Okay, let's get started. Yeah, thank you.
Sure. So last time we leave one.
You can increase the volume. Now you're coming bit low.
Oh, is it okay?
Yeah, speak now.
Yeah, is it okay now?
Okay, this is fine. Yeah, okay.
Yeah. So basically, DeepPoly maintain one upper and lower constraints, right, for each neuron, and we basically explain it will be more tightened if we maintain two lower constraints for value, right? Then what will be the problem if we maintain two lower constraints, right? Uh, can anybody try to figure out what would be the problem if we maintain two lower constraints instead of one for value?
Afzal.
Yeah.
Yeah, I think there is some echo here. Maybe you can move a little bit back to the. Yeah, can you speak up? Can you speak again? Can you repeat what you said again, please? Yeah.
So what I'm saying, last time we mentioned the DeepPoly or Chrome, they mentioned one lower and one upper constraints. Now the question is, if we maintain two lower constraints for ReLU, then it will be one more tightened because you can see, right, this extra space will save. Similarly here, this space will save, right, if we maintain these two lower constraints. Now, what is the difficulty of maintaining two lower constraints? This is the question.
Yeah, I mean, if I repeat your question, if I may do it. So you have to, you said it maintains one of the two constraints. So you have to know what happens, what is the impact if you maintain both the constraints, correct? That is your question.
Right, right. Of course, it will be more precise, right? That we can see.
Yeah, earlier, depending upon which area is bigger, you were deciding to maintain only one of those constraints, which meant a smaller area, correct?
Right, right, right.
Yeah,
So these are the either two constraints. Na? Either this one, which is saying y greater than equal to 0, or this one, right? So in this one, we have this extra space, which we are basically adding.
response here. Just wait. Let's see what.
I mean, keeping one constraint is easier for the solver to solve, probably.
Yeah, it is basically efficient to maintain one lower constraints. If we maintain two lower constraints, then constraint will blow up exponentially. How? Let us see. For example, suppose this is a neuron for which we have two lower constraints. Let's say it's a ReLU neuron, right? And similarly here also we have two lower constraints, right? Suppose this is the next layer, right? And they are connected somehow like this, right? So let's say it's x1, x2, and let's say it is x, right? Let's say it is +1 and -1, right? So x will be less than equal to x1 minus x2 and greater than equal to x1 minus x2, right? So what will be the upper expression, right? So x will be less than equal to upper expression of x1, which let's say have only one expression. So we call it, let's say, ux, or yeah, ux1, right? But it has two lower constraint, lx1, sorry, l1x1 and l2x2, right? So when we compute upper expression, it will be upper expression of x1, which is u x1 minus lower expression of x2, right? But lower, sorry, yeah, lower expression of x2. Let's say it has two lower expression, which is L1 x2 comma L2 x2, right? And one upper constant u x2. So now we have two choices here. Either we put lower expression as L1 x2, or we put lower expression as L2 x2, right? So we have two choices, L1 x2, right? Or lower expression is 4x1 minus L2 x2, right? Similarly, when we compute the lower expression of it, x, lower expression of x will be lower expression of x1 and upper expression of x2, right? So lower expression of x1 has choice. So similarly, we will have two lower constraints for x, right? So for x, we have two lower constraints, two upper constraints, right? When it basically propagate further into the next layer, uh, when it will propagate further, let's say into the next layer, then it will be a ReLU, right? Now for ReLU, how many possibilities we have? We have two possibilities for upper constraint, two possibilities for lower constraints, right? So for this neuron, we have two lower and two upper constraints. And similarly, when we propagate into the next layer, which is the affine layer, and it is again somehow connected like, suppose it is x3, x4, right? So it is connected like x3 minus x4, right? This is, let's say, some x5. So when we are computing the upper expression of x5, we have two choice for upper expression of x3 and two choice of lower expression of x3. So we have total four choices, right? And when we propagate, then in the next layer we will have total 8 choices, and so on. So these number of constraints are increasing exponentially, and handling those constraints will be very difficult, right? So that's why deep poly maintain only one lower constraint, one upper constraints. Does it clear, or is there any question here?
No, but this is about, you're explaining about the bounds, but your question was about why, how, why can't you keep both 3 and 4, correct? I didn't see the relationship. I mean, your question was regarding why not keep uh, one lower linear constraint, one upper linear constraint. Okay, 1 and 2 were constant bounds. Okay, 3 and 4 were, symbolic bounds, expression bounds. So that's what.
Yeah.
Okay.
Yes, yes.
So what is the exponentiality? Did people understand? I mean, it wasn't clear to me. Where is the exponentiality coming from?
So
Okay.
exponentiality coming from, so when we compute the upper and lower constraints,
Ah.
and we have two choices, let's say, for lower constraints. So there will be two, for example here, right? x
Hmm.
was x1 minus x2, right? So when we are computing upper expression, then we can keep one. So upper expression means upper expression of x1 and lower expression of x2, right? So when we are computing upper expression of x, it will be like x less than equal to x1 minus x2.
Yeah, but that's true. So you have to keep now, this is a disjunction. Now it's not about a conjunction. If you want to keep both,
Yeah, it is conjunction. What I'm saying, how to maintain it? To maintain,
Hmm.
the size is increasing exponentially.
Yeah, so you need to maintain uh, not just a single constraint, an exponential number of disjunction of conjunctive constraints. Correct. Yeah.
Yeah, yeah.
Is that clear? Okay. Yeah, it's not a single conjunction of constraints, but it is, you will have to, in order to be very precise, is what you're saying. But then, if you maintain one constraints also, it is not
Yeah,
precise.
yeah. What I'm saying, in the implementation, whatever the data structure we use for upper and lower
Yeah,
expression, its size will increase exponentially as we propagate next to next to next layers.
that's correct. But then you will not be able to send it out to MILP solver either if you keep doing this, correct? If you maintain such constraints. I mean, disjunction of these things. Because an MILP solver, it is no longer an LP constraint, isn't it?
Yeah, if we are using a LP solver, then it won't be a problem. But LP solver itself is basically comparatively slow in comparison to the such deep polycrown kind of methods. So if we involve LP solver, then of course there won't be a problem. But what we are saying ki in deep poly, can we maintain more than one lower constraints? So if we maintain more than one lower constraint, then it's the problem of exponentially increasing number of constraints, upper and lower. Right?
Mm. My point is, we have now to maintain two lower constraints, which means you have to solve it twice, not one for one lower constraint, another for the another lower constraint, no? So you,
Yes, yes.
yeah, okay.
So computationally, it become expensive then. Computationally as well as memory wise.
Okay, if you want it to be precise, correct.
Yes.
Okay, is that
So that's the reason deep poly basically maintain exactly one lower constraint,
okay? So,
losing some precision.
any questions on by people on the that are joined online? Okay, since they're not asking anything, I'll assume that they don't have any. Okay, so please go ahead.
Yeah. So, sir, shall we discuss the exercise regarding MILP solvers we have given previous to previous class regarding the encoding of max function? So it was something like we have a function max y is equal to max of, let's say, x1 comma x2, and x1 has lower and upper bound, x2 has lower and upper bound. Can we encode it into MILP solver? Right. So it will be something like if y is greater than equal to x1 and y is greater than equal to x2, right? And uh, y is less than equal to x1, or y is less than equal to x2. Right. Is this correct? This is the SMT encoding. Is this correct? Can anybody confirm? Just have written. I didn't verify it.
Yes.
Right. So the
Yeah.
question is, can we? So it contains disjunction, right? And MILP solver doesn't have, basically doesn't support disjunction. Instead, it supports the binary variable, which internally create the choice. So the question was, can we encode it into MILP solver by using binary variable? And the solution was, we need basically two binary variable, A1, A2, right? A1 is for X1. Basically, A1 is saying A1 is equal to 1 is saying Y is equal to X1. A1, sorry, A2 is equal to 1 is saying Y is equal to X2. Yeah, because it's a max, so it will be either one.
Yeah. You haven't shown where how A1 and A2 are used to
Yeah, that's what I'm telling.
Can you, if you showed that?
Yeah. So it will be like the YLP encoding will be like Y is equal to X1 and Y is greater than equal to X2. That is fine. And A1 plus A2 is equal to 1. Basically, it is saying either of A1, either of A will be 1. Now we have this conjunction. Y is less than equal to it is yeah, Y is less than equal to X1 plus 1 minus A1 and some expression here. I will tell you what. Similarly, Y is less than equal to X2 plus 1 minus A2 and some expression here. Right. So A1 and A2, either of one will be equal to 1. Right. So when let's say A1 is equal to 1, then A2 will become 0 because of these constraints. Right. So when A1 is equal to 1, then this will become 0. Right. So it will imply Y is equal to X1. Right. And
Yes.
Y is equal to X2 because of this constraint, and Y less than equal to X2 plus, since A2 is equal to 0, then it will be some expression here. Now the question is, what should be this expression? So the question, basically intuition is, when A1 is equal to 1 and A2 is equal to 0, then this should hold trivially, right? This particular expression should hold trivially. Similarly, when A1 is equal to 0 and A2 is equal to 1, then it implies Y is equal to X2 and Y is greater than X1 and Y is less than equal to X1 plus some expression. Right. Now in this case, this expression should hold trivially. Right. Can we basically compute this expression in terms of bound?
And
Can we say, yeah,
that expression should be expressed. Yeah, it should be such that it trivially holds good.
Yeah.
And should that expression should involve A1, A2, and possibly the bounds of X2 and X1, correct?
Yeah.
Eventually.
Yeah.
Huh?
Yeah. So are you able to see if it is some big number, let's say plus infinity? This expression is plus infinity, right? Some big number, plus number. Then it will hold trivially, right? But we want to put as tight expression as possible. At the same time, it should hold trivially, right?
Yeah, so leading to how you could solve the thing by keeping both bounds, correct? So this is a solution towards that end, correct?
Yeah, yeah,
Yeah.
right. So it should be something like upper bound minus lower bound or something,
Um,
something like this, right? Either upper bound of x2 minus lower bound of x2, such that it cover all possibilities, and it adds some number such that it should hold trivially, right? So what exactly is the expression actually this mentioned in the paper? I also didn't remember, but it should be some expression in terms of upper bound and lower bound. Now the question is why we are interested suddenly in the max function, max of x1, x2, right? And I also asked y is equal to max of not only two number but n numbers, right? This encoding for this also mentioned in the paper. So basically, this max function is used in the convolutional neural network when max pool activation is used.
what kind of activation function?
Max pool. It's a pooling layer,
A max pool.
and yeah,
Okay. What is that activation function?
I think we can't call it activation function, but it's a max pool function. Let's call it. Let's
Ma-
not confuse with activation function. It's a max pool function. Max pool. I mean, it is called max pool layer. Max pool layer, and it basically do. There are some neurons, right? It compute the maximum of all of these into a single neuron, and it used in the convolutional neural network.
Another like tanh or sigmoid, you have these activation functions have a single input, single output. This max power, I haven't introduced them in the class. So why does it take multiple inputs? Those multiple inputs are because activation function for given as I have introduced in the class.
No, sir, sorry, I couldn't hear.
Yeah. So
Could you please repeat it? Your voice was breaking a bit.
into max.
Hello.
Yes.
So, actually, sir, your voice was breaking a bit. Could you please repeat? What did you say?
I was asking you to explain the max power activation function. Okay.
Yeah.
What is the activation? What is the activation function that takes multiple inputs? Okay.
No, sorry, sir. Actually, voice is breaking. I don't know. It is only for me, but for other also. But for me, it was breaking. I couldn't understand the question. I'm sorry, but if you repeat it again, then we'll be good.
Okay, I'll try again. Can you hear me now?
Yeah, it's a better now.
Slightly better.
Yeah.
Normally, the activation functions that I have seen, like
Yes.
ReLU,
Yeah.
sigmoid, etc., take one input, gives one output. correct?
Right.
Now, here the max pole activation function has
Yeah.
multiple inputs.
Right.
Max inputs going into a max pole activation function are?
Yeah, it's basically many to one kind of function. Multiple input, single output.
I see. So they could be inputs from multiple layers or multiple nodes from the same layer. Or is that not important? Okay. So
Yeah, so it basically it reduces the number of neurons in the next layer. If suppose in this layer it has some thousand number of neurons, in the next layer it will be less than thousand. Sometimes it's half or half to half. Depends on what size we are considering here.
okay, so let's assume that we have some max pole, okay, and then
Yes.
move forward.
So basically, I mean, it's nothing but it's a max function, which
Okay,
is kind of y is equal to max of x1 to xn.
okay.
And because the question is to verify the neural network, we need to encode it also, max code. And this is how it is being encoded. Right. So here I have seen for 2 inputs, but it can be generalized for n inputs. Right. So if you have any question, then ask. Otherwise, we move out to our next, basically, yeah, next step in terms of deep poly further. Is there any question?
Are there any questions? No, you could move on. We can move on.
Okay. So now, in the first time, I mean, in the first class, when we introduce MILP solvers, someone is also asked what is the use of MILP solver. So it is slower than Maraba solver. Then why we introduce it and what is the use of it, right? So there are two things. One thing is in deep poly, and it is not basically for deep poly, but any kind of approximation function which approximate the activation function. There are 3 cases, right? We are considering Regu only, but it generalized to other activation function also. The one is if upper bound is less than equal to 0. The second is if lower bound is greater than equal to 0. And the third case is if lower bound is less than 0 and upper bound is greater than 0, right? So in this case, our activation function will be inactive. So in terms of ReLU, it will be somewhere here, right? Right. Since upper bound is negative, then it will somehow somewhere here. So it will be simply encoded as y is equal to 0. Right. Or in deep poly, it can be maintained by y is greater than 0 and y less than equal to 0. This is the upper and lower expression. Right. Similarly, when lower bound is greater than equal to 0, then our ReLU will be somewhere here, right? In the positive case, lower bound and upper bound. So here our ReLU will behave something like this. It's a linear basically. It will be y is equal to x, right? So it also can be encoded as y less than equal to x, y greater than equal to x, right? So one thing to notice here in first 2 cases we have not introduced any approximation, right? It is exactly same as the function, and we are introducing approximation in the third case only, right? When lower bound is less than 0, upper bound is greater than 0, and this is the ReLU function will become, right? And it become non-linear, right? One piece is this and one piece is this, right? And to handle it, we basically produce some kind of approximation, right? So if we get more precise bounds, then we will get less number of cases as the case number 3, right? Because if we get more precise bound, then upper bound will be smaller, lower bound will be greater, right? Then the chances of holding the first and second case will be high, right? While the chances of holding third cases will be low, right? So right now we are computing the upper and lower bound by using back propagation method, right? But can we compute more tightened bound? If we can compute more tightened bound, then we will basically our depoly will be more precise, right? It basically depends on the bound, right? And not only depoly, even simple MILP encoding will be more efficient because in most cases, first and second case will hold, right? So can we tighten the bound? And we can tighten the bound by using MILP solvers, right? How? So suppose this is a neural network. These are the layers of the neural network. Right, there are some layers of the neural network. And if we basically encode whole neural network as an MILP encoding and try to verify, it will become very slow because its complexity is exponential. What people has proposed, let us not do it. Let us consider couple of layers add together, right? Let's say we are considering three layers. Yeah.
Yeah. Is he coming through clearly? Huh? Is okay. Huh? You guys can send. Okay, go ahead then. Yeah.
Yeah. So let us consider three layers all together, and what basically doing in these three layers for each neuron, right? We compute the lower and upper bound by using MILP. So basically, these layers are encoded as an MILP query, and we compute the upper and lower bound for each neuron, right? So since MILP is exact, so lower and upper bound will be precise. Once we compute the bound for this layer, now we consider next three couples of layer, which is intersecting with the previous one. Since we have the tightened bound here, then we can compute the tightened bound for here, right? Then we consider next three, right? Three is just a number. We can also consider two also, right? Right. So we may consider as these two layers, then these two layers, then these two layers, and so on. Right. So when we do it before applying deep poly or any other approximation, so what we will get the tightened bound. And since we will get the tightened bound, then the chances of introducing of approximation will be less. Right. So before deep poly, we will use MILP bound tightening. Right. Now, of course, it will be slower than vanilla depoly because vanilla depoly will be very fast. But when we consider these two, it will be more efficient. Right. So it will be efficient, right, in comparison to vanilla MILP as a whole query, right, whole network. But vanilla depoly will be more efficient, right? So efficiency will be somehow something like this, right? While the precision will be something like this, right? So this bound tightening plus deep poly is somehow is a middle ground, right? Which is basically kind
Uh,
of
I, I want to ask the class the three distinctions that he made. I want you to be, sure that you understand. Vanilla MILP, whole net, then MILP bound tightening, which he explained, and then vanilla deep poly. Do you understand the difference between the three?
so class. Please ask if you are not able to understand. Yeah.
Yeah, these are the two things that were already discussed earlier. So I just wanted to, make sure that you did. So MLP encoding requires some lower and upper bound. Okay, so that was needed. That is what you call as vanilla MILP. Correct, Afsal?
Yes.
Yeah, and vanilla deep is with approximations, triangular and box approximations. Correct? Yeah.
Sorry, what?
What you refer to here as vanilla deep poly is the one that uses the triangular and box approximations. Correct?
Yeah, for vanilla deep poly, it is triangular approximation, which
Yeah.
we have discussed.
Yeah, and
And
then
when I say vanilla MILP, it means without introducing any approximation. It's
yeah.
a vanilla encoding of MILP.
Now, what you just now described as using MILP for bound tightening with deep poly is only computing the lower and upper bounds more efficiently, just using triangular and box approximations. Correct? Yeah.
Yes.
Yeah. Okay. Good. So there is.
So here the idea is once we compute the precise bounds, right? Let's say for all layer, then we can use our deep poly approximation to compute whole constraints and check the property.
Okay. Yeah.
Right. And this is not true only for deep poly, right? As I mentioned earlier, Marabou is also doing some kind of bound tightening. And I think alpha beta crown is also do some kind of bound tightening because it's kind of it's basically maintaining the balance between precision and efficiency. The whole game in the verification, not only neural network, but in general, is basically balancing the trade-off. I mean, balancing the efficiency and precision, right? Because in general, most of the verification problem are NP complete, which has the exponential complexity. So it's up to us how we can basically maintain, how we can maintain precision, we can reduce approximation, or we can handle efficiency. It's all up to us. And in neural network verification, this is one basically middle ground, okay, using MILP, not as fully but partially to provide the tighten bound, then using deep poly. Or we can use MILP to tighten the bound, then using Marabou as a solver to verify the property, or alpha beta crown.
Okay.
Right. Yeah. So yeah, this is one thing I wanted to mention. The second thing is we have not discussed last time. We have discussed the approximation for ReLU, but what about the approximation for other sigmoid or 10H kind of function, right? Because deep poly has provided a approximation for sigmoid, 10H, and everyone.
Other kind of activation functions. Okay. Yeah. But pose that question. I have a question. all the ones, the nuances, the different variations for approximation that you talked about, that you just now mentioned, the three different axes, okay, that you showed, are they implemented in Deep Poly or Crown, which are comparable tools?
Yeah.
And these variations, are they provided as knobs?
So basically, when they introduce, let's say, when they introduce deep poly, they have basically implemented vanilla deep poly. But
Deep Poly
when we, yeah, sorry.
no. Okay. The reason I'm saying that is because I wanted you to. I mean, if they use the tool, which of the two tools between Deep Poly and Crown would you recommend that they use? Based on that, I have this question: what kind of knobs variation in terms of band tightening, etc., that you just now mentioned, that
Yes.
we will be able to use in the tool that we provide them as a tool that they'll have to use for their next assignment. Okay? Okay. So that's why they will be doing that. Before we move to alpha, beta, crown, could you
So, okay.
spend some time explaining that?
Yeah. So all these like bound tightening and crown and PGD attack, which I'm going to explain, all these basically implemented in alpha beta crown. But
It is what?
implemented in alpha beta crown.
Oh,
And
but-
it is very active tool, active community, which is maintaining alpha beta crown very actively.
oh, alpha, beta, crown. All those things are implemented. So then your suggestion is not to use Deep Poly or Crown, okay, which are not the state of the art. They could directly use alpha, beta, crown and use one of. They have a choice of using any of these features, huh? With that.
Yes. So this
Oh,
alpha beta crown has implemented a crown and bound tightening and alpha crown, which we will discuss soon, beta crown,
okay.
right? And we can basically tune, we can set what either we want to use it as whole as one, or we just want to use crown or alpha crown or beta crown.
Yeah. So what I want them to do, so sorry for the digression, okay? But this is important because this is something concrete that they'll have to do. They're expected to do that has not been defined. That's why I'm taking this opportunity, to define that. If there are two things that they'll have to do, so they've already had an assignment in which they've taken a DNN network, a simple one, and verified some properties that we gave them, okay, using Z3. Now, for the next assignment, they'll be verifying this digit recognition network, and I want them to use tool to compare which tools that you would recommend. One was just plain vanilla Marble, maybe with bone tightening. It has, as you explained, it has Reluplex plus a lot of engineering, correct?
Right.
Sound, etc. That is one thing that they could use. The other thing is you would suggest that they directly use alpha beta crown, is it? Yeah.
I would strongly suggest to use Marabou and alpha beta crown and compare it.
Yeah. Now, but if they use alpha beta crown, what you know, options that they would use. You would have them do MILP, you know, deep poly with these approximations, etc. Those are all.
No, for assignment, I would suggest use alpha beta crown as a black box. I mean, internally they have this kind of sequence. They first use bound tightening, then use crown, or they first use PGD attack, then alpha crown, then beta crown. They have uh, all these as an internal process. I would suggest use alpha beta crown just as a black box.
Yeah, okay. Good enough
Yeah.
then. So then what you are discussing, you know, you are discussing all these different ideas, you know, that as evolutionary steps that people have investigated, and some of them have been implemented in various tools like Deep Poly, Crown, etc., as evolutionary steps you know, towards eventually alpha beta crown, correct? Okay.
Right. So basically, alpha beta crown is the portfolio tool. See, for alpha beta crown itself has around 8 to 10 papers.
Okay. In that
It
case,
means they have 8 to 10 techniques, and they have integrated all techniques. And based on the benchmark, let's say for MNIST, they are using some particular set of technique. For CFR10, they are using some other particular kind of technique,
good enough.
and so on.
Good enough.
So,
In that case, in that case, why don't you continue, you know, to introduce alpha crown? I mean, it is almost it's 5:55 now. So we started late due to technical difficulties. So I'll let you go till 6:20. Okay, that's the hard stop. You know, with people's permission. Okay, and you continue with this, and maybe in the next class you could introduce the you know, how to install, etc. And lucky, you could interact with Afzal, you know, maybe take that thing off because, you know, so I'm sorry, you know, for what.
sir, actually, I'm getting, I mean, the voice breaking, and it's, I mean, I understood, but partially, not able to understand fully.
Yeah, I think the full today has been not very good. Okay, you know, of my use, your voice also is not very clear. It's very unfortunate. Um,
Yeah.
but I can only, yeah. So I will repeat what I just now said. Okay. Um, you know, I hope you can hear it. Yeah.
Yeah.
What
Yeah.
suggests, like you suggested, there be those Malibu and alpha beta crown
Yes.
as the tools of choice. Next assignment. Okay.
Okay.
You continue to discuss alpha beta crown technique as you had planned, and you know, in today's lecture, you can go to 6:20. Okay. And we can discuss giving them tips for installation of the tool, etc. in the next class,
Okay.
or we can have Lucky interact with you to install the tool and take care of that responsibility of communicating the tool installation guidelines to the class.
Yeah. Yeah. Definitely. Sure.
Now, with that statement, I will let you continue. Okay. Thank you.
Sure. Sure. Yeah. Yeah, sure. Sure. So yeah, I'll explain about the installation. of alpha beta crown. Actually, installation is not difficult. It is very easy. I mean, you just go alpha beta crown GitHub repository, and just there are some packages you need to install. Yeah, something like this. You need to clone the directory, and then you have to create some Conda environment, Anaconda, and just you have to install few packages.
Yeah,
That's all.
can you just pause for a moment?
Yeah.
Class, you will have to ask questions generally. Okay, you cannot have crosstalks. Okay, that is not the thing. So whatever you want to ask, please ask. We cannot have
Okay.
a private
fine.
conversation between the
Okay.
two of us. Okay, while inside the class.
Sir, so I'm sorry, I had a okay. This is the last 20 minutes of class, but I had a presentation in a different class, so I was not able to attend up till here. Is it? Would it be possible to just say like one or two lines so that I can understand what is going on right now? Not possible.
No,
Yeah.
that cannot be possible, okay? Because it is up to your thing. You should have come on time, and the class cannot be adjusted to the whims of individuals, okay? So that's why we are recording it, and even if it was not recorded, okay, if I were doing the thing, for such questions should be asked after the class, okay? And that's why there are people, okay? That's why instructors make themselves available. Yeah. Okay. Yeah, please go ahead, Afzal.
Yeah. So I mean, this is how you can install easily. Then how to use it, that I will explain in the next class, because it's a little bit tricky of using alpha beta crown.
Yeah, that's a good plan.
Yeah.
Hey, please.
Yeah. Yeah. Now, okay, we have seen the approximation of ReLU. Then we have seen how the bound tightening is beneficial in deep poly, and it is in general beneficial, not only in deep poly. Now, we are going to look the approximation of sigmoid or 10H function. We will basically see one. Basically, we will see the approximation of sigmoid only. 10H approximation is same. I mean, not same, but similar. Right. Then we need to basically cover three more points. Maybe in this class is not possible, but we'll see how much we can cover. In next class, we will cover whatever is the remaining in the today's class, and the uses of alpha beta crown. Right.
Afzal, I missed there are 8 papers on alpha beta crown. Huh? You have to be summarizing the technique, correct? Huh? Oh.
No, sorry, sir. What is the question?
I saw you wrote there are 8 to 10 papers. Okay,
Yes.
I missed that. What? There are 8 to 10 papers describing alpha beta crown.
Right.
Yeah, but you are just summarizing them. Huh?
Yeah, we are basically picking 3-4 papers only. It is not possible to basically explain every paper.
Okay,
But out of interest, people can go and
fine then. Yeah,
read those papers. Yeah.
thank you.
Yeah. So let us see what is the sigmoid function first. Right. And I think instead of drawing, I can just copy some image from internet, because drawing is difficult for me. Yeah, let us put this one. Let us put this one. Yeah, actually, it is not legal to copy someone's figure without their permission. But yeah, my drawing is not good, so I have to just copy paste it. Yeah. So this is let's say y-axis, and this is x-axis, right? And we have y is equal to sigmoid of x, which is 1 upon 1 plus e to power minus x. Right. So, I mean, our ReLU was just a piecewise linear, right? They have two linear functions. One was there, one was there, right? So it was piecewise linear. But it is completely non-linear. It is not even piecewise linear, right? So how can we approximate it? Or how can we encode it directly, let's say, without very much, I mean, let us not worry about computational problem, but how we can encode it? How can we encode it? Can anybody guess? Let's say we want to verify the neural network by using MILP software.
Yeah. So your question is, if anybody have any idea about how exactly you could approximate a sigmoid function? Yeah.
Yeah.
Multiple tangents on that curve or something.
Somehow my pen is stopped working.
What he said was using multiple tangents on that curve.
Yeah, I mean,
The,
yeah,
means-
it's one possibility.
yeah, there was another hand that is up.
Using a parallelogram-ish kind of shape to enclose the entire region.
Yeah, but that's
Yeah.
approximation. Yeah, that's an
Sorry.
over approximation.
Sorry.
That's what you're saying. I have one idea that I wanted to say. Could you I know that some people
Yeah.
have used what is called piecewise linear approximation.
Right.
That could be, that's also a possibility, right?
Right. And like one person said, like we can draw some kind of tangent and
Yes, they were, yeah,
it's
like you said, tangents, and they would enclose the whole thing in a rectangle or parallelogram. Oh, yeah, parallelogram.
right. And I mean, we can do something like a small range here and something like this, right? Which is basically saying, कि, I don't know why it is misbehaving. Right, it is saying कि x minus epsilon, like x can be x minus, let's say delta, to x plus delta, right? And y can be sigmoid of x plus delta to sigmoid of x minus delta. Right. So it's a simple kind of parallelogram or a small box we create here on very small bound, and we create one kind of constraints, and similarly we can create another one here and create one here.
In mind, the loop almost had the whole thing. I mean, it's kind of a mix of the thing. So it's taking the piecewise linear approximation, but what is approximated there is what you had. Okay. Yeah. Okay.
Yeah.
Good.
Yeah. But this deep poly paper provide, I mean, in the constraint with deep poly is like we can have only one upper and one lower, one upper and one lower constraint, right? So what it could be? So if our, so again here again there are three cases. One is if our lower bound is greater than 0, right? Or if our upper bound is less than equal to 0, and the third case is like lower bound is less than 0 and upper bound is greater than 0, right? Let us see this one. Lower bound is greater than equal to 0, right? So let's say our lower bound is somewhere here, right? This is our lower bound, right? And our upper bound is somewhere here, right? So what could be the lower expression, right? Can anybody guess what could be the lower expression is. Yeah, please speak. So this line could be our lower expression, right? Right. And what about the upper expression? There can be two upper expression. One is the tangent from here. Sorry. One could be the tangent from here, something like this. And what one could be the tangent from here. Right. So either this one, our upper expression, or this one is our upper expression. Right. And we have to choose again based on the area. And I mean, we even don't need to consider in the paper they have mentioned whatever has the lower slope will be considered as the approximation. They are saying lower slope will have the less area. Right. Is this clear or not?
Is that clear? Yeah. But how about choose the lines? I mean, okay, you can choose the lower bound and the upper bound planes, and then draw the tangent line.
Yeah. So I mean, they're saying the lowest we'll choose the upper expression based on the slope, and lower the slope will has the lowest area. Now, similar thing we can do when upper bound is less than 0. Right. When upper bound is somewhere here, right, and lower bound somehow here, then our upper expression will be something like this, and lower expression will be either of one. Right. Is it clear?
Yeah, I think, yeah, at least it's clear to me. So if it's based on the lower and upper bound, you've shown the two cases. How about the third case? I mean, the third case where lower bound is negative, upper bound is positive.
Yeah. Then our third case will be something like in the ReLU we had our lower bound is somewhere here and upper bound is somewhere here, right? Then just straight line won't work here, right? We can't just say okay, this is our lower expression, right? Because it doesn't have any approximation, right? So for this case, we again need to have basically this tangent business. We'll have for lower expression we will have one tangent here, and for upper expression we will have one tangent here, right? And this will be our final approximation. Right. So that I mean that is how they are approximating the sigmoid, and 10H is also approximated in the similar way.
Okay.
Yeah. And max, they also mentioned the approximating the max pole function, which is I'm not covering, but I would suggest people to read the paper and see how they are basically approximating the max pool function. So remember, like we were discussing, max pool is something like y is equal to max of x1, x2 to xn, and for this function, they have one lower expression and one upper expression, right? Each x1, x2, x up to xn have lower and upper bounds. Right. So just check in the paper how they are doing, but it is also not very difficult.
Okay, so that's discovered in the paper is what you're saying. Yeah?
Yeah. So the other three step, PGD attack, alpha crown and beta crown, they will take some time. I don't think we can cover it now. So for PGD attack, I would suggest people to read how the neural network training is being done. Basically, how the neural network are trained, right? We need to compute some loss function and we need to update the weight and biases to reduce the loss function, right? How the gradient work here. These kind of understanding I want the student know before covering the PGD attack.
Yeah. Can you observe, for the benefit of class, can you just refresh our memory as to what the PGD attack? I think
Yeah.
that it is another complete reading on upper band using gradient descent.
Yeah. So suppose this is our neural network, right? Right, and we need to verify some property, right? And we have given some input constraints, right? Input constraints are something like this. Input can be in this region, let's say, right? So in PGD attack, what people do, they convert this property into a loss function, right? And they compute the gradient with respect to input variables. Remember, while training the neural network, gradients are computed with respect to weight and biases and update the weight and bias. But here we are considering network as a fixed network. So weight and biases are constant and we are computing the gradient with respect to input variable. Input variable means whatever the input to the network, right? And what we are saying, and suppose that was the original image. Right. Now we need to basically move this point into some direction to reduce this loss function.
Yeah. So,
And
Asmal, I have a question here. Also, into gradient descent, it is
Yeah.
done on some sampled inputs, right?
Yes. It is on
Yeah,
some sample
the
input.
assumption is that it will be it'll
Either the input is given or we can sample some input and start. I mean, it is kind of how we initialize the input.
yeah. Okay, got it.
Yeah. And then we basically update the input such that this loss function is reduced, and we are basically maintaining this loss function such that if it is reduced, it means there are the chances of violating the property. Right. So basically, we are moving this point such that our property chances of violating the property will increase. Right. So it doesn't provide any guarantee. If let's say some counterexample exists, PGD attack doesn't provide guarantee. It will definitely find out the counterexample. Also, if PGD attack is failed to find out any counterexample, it doesn't mean the network doesn't have any counterexample. But so it's kind of heuristic. It's a technique, right? It's kind of one technique which doesn't have any guarantee, but it is very effective. It is very fast and it is very effective to find out the counterexample. And alpha beta crown use this PGD attack internally, and yeah.
The reason that this, I guess the common assumption here is the property is also encoded as part of the neural network at the output layer, just like you had illustrated earlier when you were discussing the other techniques, correct? Yeah, that's
Yeah, property is encoded in terms of the output variable.
okay. So, okay, fine.
Yeah. So I mean, we'll see it by using an example in the next class and in more detail, and we'll see how this alpha beta ground has implemented it. Basically, it just not implemented its PGD attack, but it implemented some kind of upgraded version of it, which we will see. And the good thing is this, since it depends on the gradient only, it can accelerate on, I mean, all this can be done in some ML library like TensorFlow or PyTorch. And they have implemented in PyTorch, which can accelerate on GPU, which is the plus point of it. Even all the technique alpha beta crown is using, they have accelerated those technique on GPU. And this is the basically plus point of alpha beta crown. Right. So these 3 points we will cover in the next class. But first we will cover how to use alpha beta crown. Then we will follow up with these 3 points.
Okay.
Yeah.
Any questions? Yeah, okay. So sounds is a right point. I mean, a logical point for you to stop. So, I mean, I have a few things to take care of for the class. If I can request people here to hang around for another 5 minutes, okay? Yeah, okay. What is
disable my screen?
Yeah, you can take leave. Yes.
Oh, okay. Thanks.
If you want to hang around for another 5 minutes, you're more than welcome to do. Yep.
Yeah, no, I'll leave.
Okay.
You just discuss. Yeah.
Okay. Thank yeah, thank you. Yeah, I will see you next Thursday again with.
Yeah, next Thursday, same time, and I hope it will be the last class, sir, right?
Yeah, I mean, as like I said, if based on what you do, okay, I think after, yes, I mean, you will have one class, definitely one class, and if you feel one more if you wish to take, okay. But I think you should plan for another class, including the discussion of installation, etc. But then installation is not very important because that can be handled separately as well.
Nothing is for installation. I will drop my email ID, and if people have some issue, then we can connect one to one.
Correct. I think that
won't be an issue.
Yeah. Okay. Thank you.
Yeah. We can basically on email we can discuss time, and we can.
Yes. Arranged. Yes. Yeah.
Yeah. Sure.
Okay. First, I'm assuming that everyone submitted the tic-tac-toe assignment. Okay. Or those that have not, you didn't. Have you? You have. Oh, okay. Good. Then it will be graded and so on. If you have any questions on Z3, or if you want the solutions to be discussed and why you lost certain marks on the grade, etc., those things can be arranged. I mean, if you want to discuss one-on-one as to why you lost certain points, you will have to go and then talk to Lucky. And if you're not satisfied, I mean, if that his explanation, then we can escalate, and then I mean I can join the discussion. But if certain solutions to certain problems that there is, people want to discuss jointly, then that can be done in a separate session outside the thing. Number two, the next assignment, I guess the objectives are clear. Okay, one part is using TensorFlow to train it. The other part is to use that to formulate certain properties, including, two classes of properties: the correctness properties, which we discussed, which I discussed last time, and robustness properties. Okay. Those two things. Now, this is the last regular class. After that, by tomorrow, I will put up a list of papers. Okay, that will be assigned. So there will be three categories of paper. Three categories. The first two will have probably 3 papers each. The other one will have 2 papers. Okay. There are 10 people in the class. Okay. So I want to cover these 11 papers or so amongst the three, all the people. So you will be obviously 3 people for 1, 3, and 2, or 3, 2, 2. We will see how it how it goes. The reason I'm assigning 3 people papers jointly for the thing, people who are assigned to papers in the same category can discuss amongst yourselves. You can obviously read the paper and discuss any doubts that you have with me, or I've asked Afzal also to help out in this effort. And how we will schedule the presentation is what the question. So this is kind of a common problem that I have. Okay, because I have to give you some time to read. So obviously the people that are whose presentation is scheduled later will have a bit more time. Okay. Therefore, the people earlier will have I want to give at least 1 week, for you to read and present. And we have to finish up the presentation. So it cannot be, so some of the presentations have to be done outside the class hours. Okay. And I will take into consideration that the people who have to present it early on will need some time. Therefore, maybe the earliest it will start will be not next week, but starting the week after. Okay. And then I'll have to squeeze the presentation so that it will be done before the exam week starts. Okay. And that I will, the list of papers, you will have it by Thursday. And I will have some assignment based on my own thing, because I'm not going to, there could be some moments here and there. If you want to team together with some of your friends, then I can accommodate that. Okay, so those things will have to be discussed. And the finals, I had told you that I could do it as a pop quiz. With all these scheduling constraints, I'm not going to have the finals during the term. It will be on a specific date as a final exam. Okay, it will be a short final exam. I will announce the syllabus for the that final quiz, which will happen during the final exam week. Okay. So you will know what is it that you will have to, what topics that we have covered during the lecture that the problems on the quiz will be on. Okay. What else? That's all that I wanted to announce. Okay. Hey, you have any questions? You can think about it, and we always have the WhatsApp group, and any concerns and doubts and questions that you have about these things, you can always feel free to bring it up. Okay? Thank you.
I need to talk to you.